So today we are just going to solve 1500 problems, difficulty level 1500. Okay, so continuing in the same row, today we are going to solve these four problems from jury meeting to running for gold. That is 1569 C2 1552B. Okay, so yeah, here we go. So this is the first problem. So this is the ring. According to the first is jury meeting by the, yeah, now I think it is okay. Now it is in the same row. Okay, so n people gather to hold a jury meeting of the upcoming competition. The eighth member of the jury came up with the AI task which they want to share with each other. First, the jury decided on the order which they will gonna follow while describing the task. Let's say be the permutation P of number 1 to n. Okay. Then the discussion goes as follows. The jury number P1 has some task to left to tell. They will gonna tell one task to other, otherwise they will be skipped. If same thing P2 has some task left to tell, then they tell one task to other, otherwise they will be skipped. Okay, so permutation P is nice, if none of the jury member tell two or more of their own task in a row. Okay, so let's say some after permutation, um, the number of tasks of the jury will be look like this, something like 2 1 4. Okay, so it is nice if it is so no uh, in a same row, like both of these tasks don't belong to a same jury. So how this is gonna be? So now, first of all, this jury will gonna tell one task, so it will gonna remain two tasks, same one, then it will be 0 and it is 3. Now in the second cycle it will gonna tell one task, so remaining task will be 1, it will be 0, and he gonna skip out. Now here this will gonna tell one task. Okay, so remaining will be 2. Same case, now this will gonna tell, now his remaining task will be 0, this is skipped. Now this will gonna tell one task and 1 is remaining. After that, uh, this one is skipped and this will gonna tell one task. So you can see that, so in a row, so this both of these tasks of belongs to a same jury, so this is not a nice permutation. So actually we have to do that. How many nice permutation can be? Oh, so first of all, if let's say I'm just sorting all these according to the number of tasks per jury have. So if the difference is greater than 2, okay, if the difference is greater than 2, let's say task something like then 2 3 1 5, so difference of the this one of the max 2, if I'm just sorting, so the sorting will be look like 1 2 3 5, the difference between the maximum 2, because at the end the maximum to the jury have the maximum task will gonna remain. So if, so this will gonna be like skipped earlier. So if the difference between them is the greater than 2, okay, so on last two cycles only the maximum number of tasks jury will be there. So two tasks will be in a row for the same jury, so that will be not a, so we can't form any of the nice permutation. So first of all, if the difference is greater than 2, so 0 permutation will be formed. Okay, and let's say if all the edges all the judges have the same number of tasks, like say 5 5 5 5, so we can So it will always be a nice permutation, no matter how we just sort the permutation or what permutation it will be. Okay, so in this case the will be, so the result number of nice permutation will be factorial n. Okay, so no matter how I arrange all the juries, there will always be a good nice permutation. So after this conclude, if I'm just saying that difference is the from the highest one and the lowest one, highest one, difference between the two highest juries having the task is the difference. If it is greater than 2, answer will be 0. If difference is equal to 0, that means all having the same, or the top two having the same task. So I can permutate in any form, so answer will be factorial n. So the case remaining is if it is 1, if the difference is 1, so case will be look like something this 3 1 2 4. Okay, so in last two cycles, the case will be 1 0 0 and remaining will be 2. Because after, or I will say after two cycle is completed, or after two all of juries gonna tell two tasks to the others. So this will, the number of tasks will be look like this. The remaining task will be look like this. So if the maximum, okay, so the this jury has the maximum and this jury has the second maximum, second max and the maximum. Okay, task they are having, if and difference is 1, so we are talking about the difference is 1 case. And if the second maximum is appear before the before the maximum one, so it will not be a nice permutation, it will not be accounted in the array, because after the after this after this the next one will be look like this will be gonna left with 0, 0 tasks, this will be skewed and this will gonna say tell the task. After that this is the only one and this having the task, so this will look like this one. So for this jury there are two tasks in a row. Okay, so here is telling the task here and here, both of the cases in the both of the cycle he is going to tell the cycle that, or I will just input put in a same line. So first of all I'm just number the jury 1 2 3 4. So in this here first jury will gonna tell the task and then fourth jury will gonna tell the task. Now it will be appear look like that first one is having no task left to share. So after that only four having the one task, so four will gonna sell will share the task. So here you can see that 4 will come out in twice in the same. Okay, appear twice. So this will be not be a solution. And if in the same scenario uh, the the second maximum is appear after the first the maximum, so the case will look like something like that 1 2 4 1 3. Okay, now after two cycles completed, the number of tasks will be left here 2 0 0 1, and after this 4 will gonna tell the task, so here will be remaining 1, then 0 0, here will be, so first one will be gonna, so here 4 2 3 1. So these are the jury number. Okay, I'm just representing the jury number, so I'm just writing here. So this is the fourth jury will gonna tell the task. Then these after two rounds, these not having any task, second and first and second jury, sorry, second and third jury, okay, don't have any task remaining. Only the third jury having, first jury having this one task remaining. So first we'll gonna tell the task to others. After that here is the only one task remaining, on the fourth will having the one task remaining, so he will gonna tell the task. So you can see that no two tasks are in a, okay, so no two tasks are or they are repeat in the same remember and tell more of their own task in a row. So no two jury are telling their task in a same in a row. Okay, so this is possible. So we conclude that if the difference is one, so it is possible if and only if the maximum task is appear jury, the maximum number of task jury is appear before the second maximum task jury. So in how many ways this is possible? So first of all I have to, or let's say if array is something like that, maximum having the four jury having the four number of tasks, and then this one this jury having the one number of tasks, and there are three more juries having the same number of tasks, that is the second maximum. So in this case the nice array will be, this one is a nice array because 4 is appear before the second maximum, and this is also a nice array, and I will say 3 3 4 3 is also a nice array. So these are
I
the
don't
nice array.
understand. I will.
Okay, so these all the are the nice array. So the thing is 4 must appear at least before at least 1 second maximum. Okay, that I want to say. So if there are many second maxima which having the second maximum number of tasks, there are many juries, so it should be appear at least before one, that I want to say. Okay, so let me count how many possible cases is there. Mm. First of all I will take all them out. Okay, so second maximum will be how many juries? Let's say a jury is having the second maxima, that is 3. Second maximum means second maximum number of tasks. Okay, and first maximum is always 1. It is 1. If it is there are 2, then the difference will become 0. So that 1 and 2. So I'm saying that okay, these are here. So there are total people a plus 1 people are there. A plus 1 juries are there or people are there. So they can, so they can be any place. So from first of all I will choose from there are n position, I can put them in the any position. So I'm gonna choose n plus 1. So now I have chosen a plus 1 position. Okay, now how to put them in a plus 1? So first of all I put the maximum in the front. So let's say a will be 3, so I have 4 positions like 1 2, let's say a is equal to 3. So I have chosen 4 positions, so 1 2 3 4, that is n and c4. So this will give me a for a particular let's say there are so n 4 n c4 ways, I will choose 4 different positions in the n position from the n positions. So how many ways I can uh, arrange internally in the 4 ways? Now I have 4 is 4 4 positions. Now I have to arrange in the second maxima jury and the maximum jury. So I will put here that this jury has the maximum number of problems, and all these jury can be at any position. This doesn't matter how in where they can be. Okay, so this will be nc a plus 1 and factorial of a. Okay, so I'm just saying that For these first position, I am fixing for these for the maximum number of tasks jury one. Okay, let's say that is B, and here I can say like the position will be 2 3 4 3 2 4 and 4. So these jury having the same number of problems, the same number of tasks, so they can arrange by themselves in any ways. So there is will be, and the number of juries having the same task, that is A, so they, that will be factorial A. Okay, and also, or similarly, I can say, let's say, let me explain you again. Okay, it might be a little bit confusion. So now at this point, I have n different positions. First of all, what I have, let's say jury B. So I'm giving the name uh, B, have the maximum number of problems, that is 4. Now second jury, C D E F, 4 juries. Okay, 4 juries having the same task, number of problem they are having 3. So I'm saying that for now the total number of juries will be 1 2 and 3 4, that is 5. First of all, I need to choose the 5 places from the total of n. So I chosen that is equal to this one. Okay, now I have to uh, arrange them. Okay, now I have 5 places, 1 2 3 4 5. Now I have to arrange like B C D E F in such a way that is it will gonna give me answer. So I'm saying that in how many ways I can arrange them. Total number of ways. Total number of ways will be, total number of having the same 3 will be 4 and 1 5. In 5 factorial 5 ways. Okay, or I will say in general term factorial A plus 1 ways, I can arrange all these 5 members. Now from this I have to subtract, uh, so like say if B at this position, so B at the, so B having the maximum number of tasks. So if B is having at this position, so the permutation will be not be nice, because it is, because for permutation be nice, there should be at least one jury from these set, or having a lower number of problem will be behind the maximum one. Okay, so when B at this position, the task is not, or the permutation is not nice. So in how many ways, in how many ways this B is here? So B is here when, so let me fix B here, and in how many ways they will gonna switch in these 4 places will be factorial 4. Okay, so result will be, let's say it will be factorial A plus 1 minus A plus 1 minus 1 in the general term. Okay, I'm taking for the 5 example, for let's say they are having 5 1, so this will be the solution like factorial 5 minus factorial 4. If I'm taking for the general term, that is A number of having the second maximum problems and 1 is having the maximum one, so this will be factorial A plus 1 minus factorial A. So I can say that it will be is equal to, so factorial A plus 1 will can be written as 1 to A, like 1 into 2 into 3 into 4 into up to A into A plus 1 minus 1 to A. Okay, that is factorial signifies. So if I common factorial A common, so it will be A plus 1 minus 1, so it will be factorial A into A. So how can arrange internally? So now I am just arranging in these five positions, or in the A plus 1 position. So result will be factorial A into A. So that will be gonna give me nice permutation. So that will be factorial a into a. Now what I am remaining? So okay, I am done with these a positions, a plus 1 positions. Now the remaining one will be the remaining positions. On the remaining positions I can, like let's say there are 8 positions, 5 I taken, so 3 positions are left. Okay, so when I have taken the 5 positions, 3 position will always be left. In 3 positions I can arrange, let's say the jury left will be EFG in the 3 position. So I can arrange these jury in any form. So F, E, J will, so that basically it will not gonna affect my answer because I already got my answer. So I can arrange the remaining one in any form. So the remaining one will be n minus a minus 1 factorial. So I can arrange in any form that I want to say. So answer for this problem will be, if difference is equal to 1, n c a plus 1 into factorial a into a into factorial n minus a minus 1. That's the answer. So just we have to just code, we have to do a simple mathematics. Okay, we have to find the factorials and ncr, these things we have to find. So let's jump up into code. So if you anyone is understand, so you can do by yourself. Okay. I have n int n, then vector I into vector a of n. So for int I is equal to 0, I less than I plus plus c a of I. So I need to show a plus begin a dot end. So if so, difference will be a of n minus 1 minus the second one. So if difference is greater than equal to 2, I'm 100% sure the answer will be 0. And if difference is equal to 0, so answer will be factorial n. So let me, so we have to take the mode this one. Constant mode is equal to this. So first of all, let me create a long factorial of size. Maximum size will be 20 into power 1. So and maximum can be 2 into e power 5 plus 10. Okay, maximum. Now I need to check for, let's say, factorial. So for int I is equal to 1 to I less than n, or I is maximum I plus plus, fact of I is equal to fact of I minus 1 into 1 long into I percent mode. Okay, and factorial of 0 is equal to 1. So this is a simple algorithm to get the simple, or I will say simple function uh, to get the factorial. So factorial, let me run the factorial. Now I have a vector of fact or array effect. So answer will be, if difference is 0, that will be fact of n. Written. Now we have a case difference, that is difference is equal to 1. So difference is equal to 1. So int long answer is equal to NCR, I need to define the NCR function. NCR will be factorial n, we have to choose, okay, and second maxima. I will say second maximum. How many are second maxima? So for int I is equal to n minus 2 I plus plus I less than is equal to 0 I minus minus. If a of I is equal to a of n minus 2, so I will gonna increase second maxima, else I'm gonna break it out. Okay. So first of all I have to choose number of position, that will be this one. Then I need to factorial of uh, second maxima into a into second maximum. Okay, so here we see second maxima into a. So I will go to this one. Now I will go to this one, second maxima into a. Now I have to put answer is equal to answer into factorial of n minus 1 minus second maximum. That's it. So I need to output this answer. First of all I put the max. Here we go. Okay, yeah, good. So now I have to implement the NCR function. So in n int r. So basically it is, so I have already maybe NCR factorial. If I am having NCR, what do I have to write this? I don't have. So will be, so long numerator will be so NCR, what will be NCR function? So NCR will be, so NCR is equal to factorial of n factorial of r into factorial of n minus r. That will be the, so factorial of n into factorial of r factorial of n minus 1 r keep power mod minus 2. That is, I need to calculate this one basically. So this will be factorial of n, denominator will be factorial of r n minus r. I'm a little bit confused. It is factorial of r into n minus r or both? So let me search what NCR is. Oh, n permutation NCR maths. I was gonna say math formula. So yeah, I'm right. N factorial r factorial minus 1. Okay, so will be factorial n and factorial of r percent mode. Okay, now for I need to take a power. So denominator will be is equal to power of deno into mod minus 2. Okay, so I have the power function, by the way. That's the thing. Yeah, I have this one. So these are typically, I can say, kind of standard functions. Okay, so you don't have to worry about this. So pow POW. Okay, so answer will be numerator is equal to numerator into 1 denominator percent mod, the remainder then I'm gonna return this numerator. Yeah, here we go, NCR. So yeah, I think so this will gonna give me answer. 16054. 100% true. Yeah, accepted. Okay, so my laptop battery is going to dead now, so I have to stop. Sorry for that.